Hello friends, welcome to SR Physics Academy. In this video, we are going to learn about motion in a straight line, distance and displacement part 2. Before we start about distance and displacement, let us discuss about motion and rest. When a body does not change its position with respect to time and its surrounding, the body is said to be at rest. For example, if a car is placed in the garage, then the wall of the room or its surrounding, if the position of the car does not change with respect to the house as well as time, then the car is at rest. When the position of a body continuously changes with respect to time and its surrounding, the body is said to be in motion. In other words, when the position of a body continuously changes with respect to the reference point and time or any stationary object around the body is said to be in a state of motion. Let us look at the picture. The girl beside the tree is resting. For her, the cyclist on the road is in motion as it changes its position with respect to its surrounding and time. Now, what is distance and displacement? Distance and displacements are two quantities that seems to mean the same but are distinctly different with different meaning and definitions. Distance is a measure of how much ground an object has covered during its motion, while displacement refers to the measure of how far out of place is an object. So in this case, let us understand the difference between distance and displacement. So distance is the length of the actual path, while displacement is the shortest distance. Okay, that word is important. Shortest path or shortest distance between the initial and final positions. So now here, what is the A to B? What is here distance? The total distance travelled by an object. Then this is, we can say that distance. Now, so displacement is what is the initial point and final point. Here what is the initial point? This is A, and what is the final point? B. That is, we can say that the shortest path in a straight line between initial and final positions. Now, so we will discuss one by one what is distance. Distance is the actual length of the path travelled by the object. That means the length of the any path travelled by an object is called distance. Distance is a scalar quantity because it has only magnitude, no directions. Distance travelled by a body can never be zero. So, if a car is moving, then it will be changes its position with respect to its surrounding. So, the distance travelled can never be zero. Okay. Next is here, the distance can be positive or zero, and then we can say that odometer is used to measure distance traveled. So we will discuss one by one. So now we know that what is distance? The length of any path traveled, the length of any path. Okay, this is a straight line path. So the length of any path traveled by an object is called distance. That's clear. Now we know that the distance is a scalar quantity. So what is the meaning of here scalar quantity? Because it has only has magnitude, no directions. We are not specifying no direction here. So that is the distance. Next is distance traveled by a body can never be zero. So what is the meaning of in this case? For example, car is moving, then it will be changes its position. So this is the initial point, okay, starting. So the changes from 0 to 1 kilometer. Okay, so if a car is moving, then it will be changes its position with respect to its surrounding. So that then the distance can never be 0. In this case, the distance can never be 0. But since it is, we can say it is a scalar quantity, then distance will always measured be positive. But if a car is not moving, when it is at rest, then the distance traveled will be 0. So now we will discuss the total distance it is covered from 0 to what is the initial point, the total covered, the length of the total covered. So now 0 to 3 kilometer, then again the car is coming back. Now tell me what is the total distance covered this car. So that means the on the way what is the kilometer here? 0 to 3 kilometer. Okay. So first is 3 kilometer. That means you consider this is the A point. So 3 plus then return back again. It is reached same position. So 3 plus 3 total. The actual length of the path travelled, this object means car. So total how much? 3 plus 3 equal to 6 kilometer. So we can say this is the distance actual path. Now what is the distance of means here the car is passed. The distance is the actual length of the path. So what is the actual length of the path travelled by the here? First is 0 to 3 kilometer. Again return to back. So we can say 3 plus 3 kilometer. Now odometer is used to measure the distance travelled. Now what is displacement? Displacement is the shortest distance between initial and final position of the object. So then we can say this is displacement. We know that the displacement is the vector quantity. Displacement travelled by a body can be 0. Displacement can be positive, negative or 0. So we will discuss each point here. So what is the displacement travelled by a body can be 0, displacement can be positive, negative or 0. Let the car move from initial point. Okay, so this is it is considered as a 0. Okay, 0 means it is we can consider this is the initial point. Now move from initial point. Now when it's move forward, so 1 kilometer. Again 2 kilometer. Okay, that means forward or away from the point. From means here we started this is A, that means initial point. Okay, from initial point the away from here. So in this case what happened? The displacement is increasing. How the displacement is increasing? Because this is the starting point, then it is increasing 1 kilometer, 2 kilometer, 3 kilometer. The displacement is increasing, but when it is coming back, the position of the car with respect to the initial position, it is decreasing continuously. See, this is the starting point. So it is go away from, that means what, the displacement is increasing in this case. Then again it is coming back, so the displacement is decreasing. And when it reaches back, okay, when it is reaches back, again it is reached what, same position where it is the initial point, then where it is here final point. Then this cases the displacement will be 0. Clear now? Where the displacement, what is displacement? Is the shortest distance between initial and final position of the object. So in this case, what is the initial point? So starting here only, okay. So this is the initial point. Again it is moving 1 kilometer, 2 kilometer, 3 kilometer. So when it is increasing, so the displacement is increasing. What is the displacement increase means? It is far away from initial point. Then again it is coming back, okay, same position, the displacement is decreasing. So in this case, the initial point and the final point or final position, both are what is the same position it is reached. So that in this case the displacement will be 0. Now when the car goes behind the origin, okay, so this is the origin case or initial point. So it is behind the initial point, then the displacement will be negative. So it's clear. So the displacement can be positive, negative or 0. This is the meaning. So here when it will come, the displacement will be 0. That means final minus initial. So here I started 0 kilometer or starting here, or we can start from 1 kilometer. Suppose 1 kilometer it is starting. How we can say that this is the initial point. Then again the car will go, car will go back same position. Then we can say that how we can conclude that the displacement final position minus initial position. So in this case the displacement is 0. Wherever it will start, wherever it will come back, same position, that is displacement. Now suppose here it is starting from from starting 0 here, then it is going back, again it is coming back, it is 1 kilometer, it is reaching, it is not reaching the same position, okay. So here what will come here? Here this is the final, okay, this is the final means it is 1 kilometer, we can say 1 kilometer minus, what is the initial? It is here I mentioned here 0, okay, not 0, it is just mentioned the origin. Then we can say that it is it is positive, okay. Now you understood what is 0, what is positive. Now when the car goes behind, wherever the starting, okay, the starting that behind the initial point or origin, then the displacement will be negative, okay. For example, here we can say that it is starting from, okay, this is the origin starting, then minus, then it is coming to reverse, then we can say that it is the negative displacement. So now it's clear what is distance and what is displacement. Now the distance and displacements are measured in the same unit. So we know that what is that? It is an in CGS we can say that the centimeter, and in SI unit we can say meter, because both of them are in measure of length. See, measure of length we can say that it is a kilometer, or how many, 100 meter, 2 kilometer. This all we are using in meters only. Now we will discuss what is its more depth we can understand. Understanding distance and displacement. So here I have taken distance and displacement in two-dimensional. Which graph is that? Linear path. Okay, this is a linear path. Suppose you are traveling in a two-dimensional linear path. So this figure it is given. In this case, what is your initial point? Initial point is marked by A. If you reach the position B, then see the arrow mark, it is showing that is this person, it is going A to B, B to C. The distance you travel, okay, then how we will calculate? So as we know that distance equal to, we have to take it, what is distance? It is the total length, okay, total path covered. So in this case, this person is moved from A to B, B to C. So we have to take it A to B distance and B to C distance. So here what is AB? AB equal to 8 meter and BC equal to 6 meter. So the person, it is here, what is the total distance it's covered? 10 meter. Clear? That means total, how much he means covered this path. So A to B, B to C. Now we have to calculate displacement. Displacement in this case, see, we know that what is displacement? It is the shortest path from initial position and final position. So now we can, it is a straight line path. So it is no need to go to A to B, B to C, where it is a starting point A, where it is the ending point C position. Okay, final position, sorry, initial position and final position. So directly we have to take the straight line path. So here, initial position here A and final position is here C. The displacement you will is the straight line path. That means we can say AC. Okay. Now this can be measured by applying, we know that, Pythagoras Theorem. Here ABC is a triangle. So we have to use the hypotenuse of this triangle is the displacement. So in this case, as we know that here AB distance and BC distance, that means displacement equal to root of AB square plus BC square. So what is the displacement? What is AB square? We will get 8 square plus this distance BC 6 square. 8 square 64 plus 36. So we will get 100 meter. Square root of 100 we will get 10 meter. So we can, so in this case we can get it. Distance also, displacement also. Okay, but in displacement we have to specify the direction because it is a vector quantity. Now next we discuss about here distance and displacement in two-dimensional circular path. Now suppose you are traveling in a circular path. So in this given figure, your initial position is marked by here, this is the initial position, and if you reach the position here, just B, okay, just we will mark it here, this is the A position, this is A position, just you take this the half of that, this is the B position. Okay, it's clear now? Yeah. So first, okay, just to see here the position of B. So now what is the initial position here? This is the initial position is marked by A, and if you reach the position B first, then the distance you will travel will be the half of the perimeter of the circular path. Clear? Where the displacement will be the diameter of the circular path. So what is the displacement here? Where the displacement is the, what is the diameter of the circular path? Because the shortest distance between A to B is the diameter, because we are taking here the half circle. of the circle. Now again if you back to the initial position, okay, again it is coming to B to A, initial position. Then A here, what is here? That is here A. Okay, initial position is if A become your final position. So wherever the initial position starting, then again it is you reached back, that is our final position B. So then the distance you will travel will be the perimeter of the circular path. Okay. So in this case, what is the displacement? The displacement will be 0. Why the displacement will be 0? Because there it is no separation between initial and final position. So there it is no shortest distance between them. That means initial, where it is initial, where it is final. So when we calculate the displacement, what is the here? The shortest path here? The difference between final minus initial. So here final is also A and initial is also A. So in this case the displacement is 0 because there it is no separation between initial and final position. There it is no shortest distance between them. Now we will discuss in the first case. Here, what is the first case here? The distance covered, okay, the distance covered in what? Semicircle track. Okay, in the semicircle track we can say it is the pi r. Displacement in semicircular path is diameter. What is the diameter here? 2r. That's already you know that. So now we calculate the semicircle. We know distance is pi r and displacement is 2r. Here r is the radius of the circular path. Next is second case. In this second case we covered here, it is full, okay, full circle we covered, where it is initial point, where it is the final point, that means 1. So if a runner runs a single round around a circular track, the total distance become 2 pi r. When it is a half, the distance covered in a semicircle, we got it pi r. But if a total distance become, in this case, around a circular, okay, that means we are taking the full circle, we will get the distance is 2 pi r. The r is the radius of the circle. But the displacement of the runner become in this case 0, as after completing one round in the track, the starting and the end point become same. Okay, just we discuss here what is the initial, because we know that the displacement is the final point minus initial point. So here final point is A and initial point is also A. So in this case we will get the 0 displacement. And the distance between them is also 0. So once more here I am explaining what is distance. Distance covered in semicircle track is pi r. Displacement in circular path is diameter 2r. Okay, that it is we have taken here half circle. When we are considering as the complete circle, if a runner in a single round around a circle path, the total distance we have 2 pi r. But the displacement of the runner becomes 0 as after completing one round in the track, the start and end points become the same and the distance between them is 0. If you like this video, please subscribe our channel. Thanks for watching.